So, the aim of this video is to perfectly understand the hidden conditions mathematically in a physics problem of frictions, which many people miss out and they struggle in finding out the right conclusions by using the concepts. This video's purpose is to perfectly convert the concepts of physics mathematically and seek out the right answers. But there is a small recommendation from my side that it would be better if you go on with your own instincts while finding out the answers rather than converting them mathematically like how I'm going to do it right now. This video just gives you a right path and just tells you that math is always right. So let's start. So in this problem, we have two masses and F forces applied on M1, and I've got two accelerations A1 and A2 here, and the coefficient of friction between two blocks is mu, which is 0.5, let's suppose. Now, if ground is smooth, what is that law by using which you can find out the acceleration of both of them? If there were mass m1 is 5 kg suppose and m2 is 10 kg, then we have to find out, and f is also some force, then we have to find out the acceleration of both of them and also the frictional force between them. So first of all, we talk about what actually causes friction. Some people will say that friction opposes relative motion. Some people will say that friction opposes the tendency of relative motion. But the real answer is pretty deep. And if we always make our mind instinctually and we think about it ki friction always opposes, then you are wrong. Way too wrong. We even have examples regarding that. First of all, friction comes when there is a contact. It's an old view of friction. The new view is also something else, which we can cover in next video. So one of the surface of the contact is like this, and second is like this somewhere. Sorry for the overlap, just ignore it. So you need to look out for the points of contact which are very very small, and because of this very small area, when we push or just keep anything and even the slightest amount of forces, these small contacts make some cold welding. Have you heard about cold welding? Cold welding also happens in space when there are two same type of metals and they don't have any oxide layer on them or any impurities. If we even just touch them a bit in space, they permanently weld together, as they both believe, their surface atoms believe that they were the part of itself, which means that this block's surface atoms will think that this block's surface atoms were bonded with them always. So they just bond together. The atoms just bond together and they behave like one. This is cold welding. Sorry, my English is weak. So something like that happens here also. The atoms here bond together to cold weld themselves, and the joints are formed here. So friction just doesn't want that joint to be broken. Friction wants that joint should remain always. In general, you can we think that it's the same thing, a position of relative motion and keeping the joints, but those are two different things. There are many different examples for that. One of the examples is this question itself. So now people say that we make two cases. First, the acceleration is same, and the second in which acceleration is not same. But which law governs it? Which that fundamental law that governs this conditions is one of the laws of friction, which says that frictional force cannot cause relative motion in any circumstance. It is a law. Law is a rigid, I am saying rigid, fundamental fact which cannot be changed. You cannot argue with it. If I say that friction cannot cause relative motion, it's a law, which means you cannot argue with it in any circumstance. Law is the most fundamental. Okay, so this is the law. Friction cannot cause relative motion. It is quite obvious also. So by this law we have this condition regarding this problem. This is that one mathematical condition which we need. That one mathematical condition which fills in the gaps of all the equations. Okay, that A2 should be less than or equal to A1. Now what if this condition were not to be here? If it was not fulfilled, that is A2 was greater than A1, then the FBD of M2 would look like this, that M2 applies M1 applies a frictional force on M2 here, and M2 applies a friction force on M1 here. So if A2 was greater than A1, then that would mean that in ground's respect you are applying force on M1. You are applying force on M1, but M2 is going faster. And by this statement you can also see that in this situation F is causing the relative motion. If we sit on M1 and then draw the FBD, we will find out that with respect to M1, it's 1, okay? So with respect to M1, M2 will move like this. This is M2. The acceleration is here, and this is A2. And now for relative to M1, we will just oppositely add A1 here, and the frictional force was always here. So as we know that A2 is greater than A1, by this, if it was not fulfilled, we are just taking A2 is greater than A1, then that means that A2 minus A1 is greater than 0. That means M, now this is A0, A net. So M into A net would be equal to F, which means it is actually moving here. Relative to M1, this is moving here due to the frictional force, but this is not possible. This means that frictional force is causing the relative motion of M2, which is not possible. Not possible. Possible. And this is a little far situation right here. Okay, so this is the mathematical conditions. Let's see if we can find out some more insights about it, if there are some. I think this is it. So many people make the cases it is to fulfill this equation right here. This is the hidden equation, and if we take the acceleration as equal, then if this is fulfilled, then it's okay. But if A2 is less than equal, then it is fulfilled, then it is also okay. we have to take that equation in hand, in which case the frictional force is not causing the relative motion. Any one of these cases, if it is fulfilled, then we get our answer. Just check for one thing, if the frictional force is causing the relative motion or not. This law is the most important. This law is the one which will change everything. Okay, so this is it. All right, bye ji bye.